3.6a, we're going to look at asymptotes and how they tie in with limits. So let's look at this example. Here we have a vertical asymptote and horizontal asymptote. As a reminder, I'm going to call HA for horizontal asymptote. We must write this in an equation of a line, and the equation of this line is y equals 2. And then for our vertical asymptote, the equation of that line is x equals 2. All right, now let's look at our graph. This vertical asymptote, as we approach 2 from the right, we notice f is going to infinity. And as we approach 2 from the left, f is going to negative infinity. So this is how we tie in our limits. In order to have a vertical asymptote, the limit of f as x approaches a from the right must equal plus or minus infinity. Likewise, the limit of f as x approaches a from the left must equal plus or minus infinity. Okay, now let's look at the horizontal asymptote. Here's the horizontal asymptote. Now what we do there is we say as x approaches infinity. So as x approaches infinity, as x gets bigger and bigger, f of x is approaching right here, 2, y equals 2. Okay? Now as x approaches negative infinity, f of x is also approaching 2. So let's write that in terms of limits. In order to have a horizontal asymptote, okay, the limit of f as x approaches infinity equals plus or minus a, some number. Similarly, as limit of f of x approaches negative infinity, then that must equal plus or minus a. Okay, so we're going to utilize that today. I like to go straight into what we've learned previously about vertical asymptotes algebraically.